Hi, my dear students. Today we are going to do some more problems in the series. Right, here I have written as 10 questions in this from the exercises of the SOTI textbook. And the first one is summation n equal to 1 to infinity 1 by n into n plus 1, n plus 2. This is like a telescoping series. Right, so I can write this as we can do this and we have to check whether this converges or not. If it is converges, find its sum. That is the question. Okay, so consider the first question. Summation 1 by n equal to 1 to infinity, n equal to 1 to infinity, n into n plus 2. This can be done as this is equal to 1 by n into n plus 2 is equal to what I have to return here. This equal to 1 by 2 into 1 by n minus 1 by n plus 2. Is it okay? N plus 2 minus n, and that will be 2 divided by n into this. So that 2 get cancelled. So this is 1 by 2 into this one. Okay. This is equal to how I got this. Just to write a by n plus b by n plus 2. And this will be a into n plus 2 plus b into n. So this is a plus b into n plus 2a. So a plus b equal to 0 and 2a equal to 1. So a equal to 1 by 2 and b equal to minus 1 by 2. So we can write this way. Right? So series can be written as summation n equal to 1 to infinity. 1 by 2 is taking outside. 1 by n minus 1 by n plus 2. So what will be this Sn? Sn is equal to summation by 2 into n equal to k equal to 1 to n 1 by k minus 1 by k plus 2. K equal to 1. What happened to this? 1 minus 1 by 3 plus next to k equal to 2. K equal to 2. That's equal to 1 by 2 minus 1 by 4. Next is 1 by 3 minus 1 by 5. Right? Next is plus 1 by 4 minus 1 by 6 plus 1 by 5 minus 1 by 7 plus etc. Last two term is n minus 1 by n minus 1 minus 1 by n minus 1 plus 2 n plus 1 plus 1 by n minus 1 by n plus 2. Right, what happened to this one? Up to n equal to 4, you will get this will get cancelled. This 1 by 4 get cancelled. 1 by 3 get cancelled. 1 by 2 is there. 1 by 2 is there. And 1 by 6 is remaining. And minus 1 by 5 is also there. Up to 4. Minus 1 by 5 is there. Right. So, the remaining here, the remaining term is 1 by 3, 1 by 3, 1 by 4, 1 by 4, 1 by 2 is there, 1 is there, and consider up to these work. 1 by n get cancelled when 1 by n minus 2 is there. This is not included. 1 by n minus 1 is also included. 1 by n minus 1 is there. 1 by n is not there. And here the remaining is 1 plus 1 by 2 minus 1 by n plus 1 minus 1 by n plus 2. These are the terms in this. That's equal to 3 by 2 minus 1 by n plus 1 minus 1 by n plus 2. So this is Sn actually, right? So this is Sn. So limit n tends to infinity Sn. This equal to limit n tends to infinity 3 by 2 minus 1 by n plus 1 minus 1 by n plus 2, which is equal to, this will be 0 and the remaining is 3 by 2. Next, to consider the next question. 2 and limit Sn is equal to 3 by 2. What will be, this is equal to, limit of Sn is equal to, that is the sum exists and the series is convergent. Done like this. Limit Sn is equal to this one. How can we see that? That is the limit of the partial sums is equal to s, and the series converges and has a sum s. Right? Using this assumption, we are doing this. Okay. So consider the next question. There is sigma n equal to 0 to infinity 2 by 5 raised to n. Actually 2 raised to n, this is 2 raised to n by 5 raised to n, right? I will give some notes, I think, otherwise it will take some more time, right? I will give some just a hint for these in order to doing this. So you have to do this perfectly, right? This 2 by 5, this can be written as 2 by 5 whole raised to n, right? 2 by 5 whole raised to n. Then what we have to do? This is 2 by 5 is less than 1. This is a geometric series, right? So this is a geometric series. So this is the r here. 2 by 5 is the r, which is less than 1. So this is convergent and converges to what? A divided by 1 minus r. Okay. Here also look this. This is 3 into 3 raised to n by 5 raised to n. 3 into, this can be written as 3 into 3 by 5 whole raised to n. I can take this 3 outside in this. Right? And this is a geometric series. Again, this convergent and converges to this 3 into this a divided by 1 minus r. Right? You do it. Okay. I think I have to do this. This equal to this is a geometric series. The common ratio r is equal to 2 by 5 in this, which is less than 1. So converges. So converges and converges to the value. A is here 2 by 5 n equal to 0. That's equal to 2 by 5 Sn. When I'm taking this Sn, 2 by 5 is 1. First term, that is 1 divided by 1 minus 2 by 5. That's equal to 1 divided by 5 minus 2. That is 3 by 5. That's equal to 5 by 3. It's equal to 5 divided by 3. And the third one is 3 raised to n by 5 raised to n. These type we have to do, right? Next, fourth one is summation 3 raised to n minus 1 divided by 3 raised to n plus 1, n equal to 1 to infinity, which implies summation n equal to 1 to infinity 3 raised to n divided by 3 raised to n plus 1 minus 1 by 3 raised to n plus 1. Which implies summation n equal to 1 to infinity, this is 1 by 3 actually, minus 1 by 3 raised to n plus 1. Okay, and this is actually what happened to this one. I think this will this is equal to, this is a sum, this will diverge actually. This is a geometric series, but this term, this series, this is a constant series, right? So there is diverges, but this is converges, but in total this is diverges. What happened to this one? N factorial divided by 2 raised to n. In order to find the limit, in order to find the limit of this n factorial by 2 raised to n, as n tends to infinity, this n factorial will be large. Okay, and this is when compared to this 2 raised to n, this will be large, right? So this an limit an as n tends to infinity actually, and factorial is large as compared to this 2 raised to n. So this tends to infinity but not equal to 0. So we can say that this is diverges. This is diverges. Next to this one, summation n equal to 1 to infinity log of n by n plus 1. I can write this as log n minus log n plus 1, right? Summation. So Sn is equal to what? ln1 minus ln2 plus ln2 minus ln3 plus ln3 minus ln4 plus ln4 minus ln5 plus etc. plus ln minus ln plus 1. This will get cancelled and the remaining is equal to ln1 minus ln plus 1, which is equal to ln1 divided by n plus 1. Okay, as n tends to infinity, what happened to this one? This equal to, as n tends to infinity, this is 1 by infinity 0, which will be tends to log 0, natural log of 0. And natural log of 0, that becomes what? That is, which is not equal to 0, that is it tends to minus infinity. Okay, so we have to do this carefully, right? We will do the next problem in the next video. Okay, thank you.